Hi, Core Chemistry. Mrs. KJ here, going over the lesson 5.0 for types of reactions, part 1. There are several different types of chemical reactions. Chemists are like other scientists in that they love to classify. The benefit of classifying different kinds of chemical reactions is that one can easily refer to a reaction as a combustion or synthesis, and other scientists immediately understand the chemistry that is being discussed. In this lesson, you will learn about different types of chemical reactions. So you start with compounds. If they react with oxygen, it could be a combustion reaction. If compounds are formed through a synthesis reaction, and compounds break down through a decomposition reaction. So the goals for the lesson: recognize the different types of chemical reactions, define combustion reactions, compare and contrast the products and reactants of combustion reactions, define synthesis reactions, compare and contrast the products and reactants of synthesis reactions, define decomposition reactions, compare and contrast the products and reactants of decomposition reactions. All right, so if you'd like the study guide, you're going to have to log in order to get that and download it from the link. Explore. As you read, take notes, whether you take them on the study guide or just your notebook. Make sure you are taking notes. And again, you can't use your notes on the test, but they are going to help you to study. And you cannot use them on the quiz as well. All right, chemical reactions can take several different forms. So let's look at the picture. We have sulfur burning in oxygen is a combustion reaction. So combustible, combustion, all those, you should usually think about fire or explosions. In flash cubes, magnesium and oxygen combine in a synthesis reaction to produce a bright flash. And mercury oxide is broken down into mercury and oxygen in a decomposition reaction. There are many types of chemical reactions. This lesson focuses on 3 types of reactions: combustion, synthesis, and decomposition. As you learn about these reactions, you will study examples that may be relevant to your life. Combustion reactions involve oxygen and fuel. All right, so let's get this in your notes. Combustion reaction equals a chemical reaction between a reactant and usually oxygen gas. So hit pause if you need to add that down. I want you to add more, though. That's not enough. I don't like that that's all they put for it. I also want you to add energy is a product, and then write down example, fire, comma, explosions. So having energy as a product is a big thing. And in fact, it's written like this. So you have the reactant, whatever the chemical is, plus the oxygen, boom, fire. You have whatever's produced, like ashes and carbon dioxide and some water. But you also have energy. And so we actually write it as plus energy. And, oh, that's crazy small. Let's try to make that a little bigger. And you can see that here they have your chemical, your compounds reacting, plus the oxygen. It yields carbon dioxide. Also water, which is really weird to think of that water is a product of fire. Yeah, think about that for a minute. But a good way to test that is if you have a candle, put a jar over top of it, and you know that the oxygen will run out and the flame will go out. Well, if you have a big enough jar and you have the top of the jar close enough to the flame, you'll start to see some condensation on the inside top of the jar. So you'll actually see that water collecting. And then listed separately, we have our energy, which is heat and light. I know the word light here is cut off a little bit. So there you go. Heat and light. So we have the energy listed separately, but on the product side. In a common combustion reaction, a fuel is combined with oxygen to produce products with the release of some form of energy. This energy is quite often in the form of light or heat, or both. Written simply, it is reactant plus oxygen, O2, yields product plus energy. Oxygen's always O2 because remember each oxygen, which is in group 6, has 6 valence electrons. It really badly wants a full outer shell. And so oxygen is never one single atom. It always combines with itself into a diatomic molecule. All right. Gasohol is a mixture of gasoline and ethanol, a type of alcohol. Gasohol is used in many automobiles and gasoline-powered vehicles. The combustion of gasohol follows the general formula for the combustion reaction. When gasohol is burned in the presence of oxygen gas, the ethanol in the mixture, C2H5OH, is combusted in the chemical reaction shown here. So you probably hear about ethanol at the pumps when you fill up with gas, so this would be the reaction of ethanol combusting. Reactions often involve a hydrocarbon as fuel. Okay, so why don't you write down hydrocarbon? Hydrocarbon is a molecule made up of hydrogen and carbon, hydrocarbon. And actually we do an entire unit on hydrogen and carbon, hydrocarbons and other forms of carbon coming up. The ethanol example involved the burning of a hydrocarbon. A hydrocarbon is a compound made up of hydrogen and carbon. Hydrocarbons include wood, coal, gasoline, methane, and natural gas. Hydrocarbons are used to fuel vehicles, heat many homes, and produce electricity. The combustion of hydrocarbons is vital to our lives today. A generic chemical equation for the combustion of hydrocarbons is a hydrocarbon plus oxygen yields carbon dioxide plus water plus energy. The combustion of hydrocarbons releases a significant amount of energy. Gasoline in a car's engine burns in a combustion reaction. Gasoline that is used to fuel cars and other vehicles is a combustion of hydrocarbons. The unbalanced chemical formula for gasoline is C8H18, and the unbalanced chemical equation for combustion of gasoline is 8H18 plus O2, so oxygen gas, yields CO2, carbon dioxide, plus water, plus energy. This is the reaction behind the internal combustion engine. In other words, what's inside your car and makes it go, which is the basis for all modern cars and many other machines. The balanced reaction for the combustion of gas is 2C8H18 plus 25 O2s yield 16 carbon dioxide molecules plus 18 water molecules. And notice they didn't put energy over here. You don't balance the energy with coefficients. That part you don't do, but it still should be here plus energy. So again, we balance our chemical equations. Why? To show the conservation of mass, the law of conservation of mass, that we have the same amount of each element on each side before and after the chemical reaction occurred. In the presence of a spark, this reaction can create a lot of heat and light. If that reaction is contained in a cylinder, the explosive reaction puts tremendous pressure on the walls of a cylinder. If one end of that cylinder is a piston, the piston moves quickly onward. So in other words, that's how your vehicle works. So let's learn a little bit about your vehicle. So we have the combustion engine. We have intake, compression, power, and exhaust. So let's take a look at these different parts. We have an intake valve. Okay, so here's our valve. We have the combustion chamber, so where the combustion is going to happen. This is all enclosed in what's called the cylinder block. So if you ever hear of a cracked cylinder block, it means that this cracked and it's expensive to fix that. The crank shaft, so this is going to turn, and if you see here the connecting rod connects the crankshaft to the piston, and when this rotates, it's going to pull the piston up and down, which is going to change what's going on here with our intake valve, combustion chamber. We have an exhaust valve, and then we also have the spark plug. So this is where our spark comes from. All right, so the intake, we will see that the mixture goes in. Okay, so we're talking about the mixture. We're talking about some gasoline, some oxygen. And then we compress it. Okay, well, what happens to these gases when we compress them? They get closer together, right? And when they're closer together, they're bumping into each other a whole lot. And then we have that spark. Did you see that little tiny spark? It's very, very quick. Boom. The crankshaft is also turning. So you can see here our crankshaft is turning. We have a lot going on here at once, which is causing the piston to go down. And you can see the exhaust is going out. Okay, so this repeated process here is happening in your car. Pretty cool, huh? So this just shows how you use chemistry every single day and probably don't think about chemistry with your car. All right. So that was combustion. Our next type of reaction that we're going to talk about is synthesis. So a synthesis reaction is a reaction in the general form of A plus B yields AB. So in other words, two compounds or elements, or a compound and an element. So at least two chemicals are going to be added together, and they yield one product. So in a way, it's kind of like you have two things and you super glue them together. A reaction is called a synthesis reaction when two or more reactants combine to form one product. The generalization, again, is A plus B yields AB. So I'd put this example in your notes, and then also that multiple reactants combine to form one product. Well, here is we have two atoms of potassium are going to react with a dichloride molecule and produce two molecules of potassium chloride. So it's okay that there's multiple molecules over here, because we just need the multiple molecules in order to balance it. But there's multiple reactants, so at least two different chemicals reacting, and they come together to produce one product. Another example, two sodiums plus dichloride yields sodium chloride, or table salt. Many common substances are the result of a synthesis reaction. Our planet is roughly 75% water. Your body is largely made up of water. Water is a substance that can be formed by a synthesis reaction. To form water, hydrogen and oxygen, two reactants, combine in a chemical reaction to produce water, a single product. Formation of water is both a synthesis reaction, because we start out with at least two reactants and make only one product, and a combustion reaction, because what do we see for our clue? We see this energy over here. And the reason it's also a combustion reaction is because hydrogen gas is combusted in the presence of oxygen. That's how this reaction is both. It's a synthesis, because we start with multiple reactants and make one product, and it's combustion. We have energy as a final product, and look, we have something reacting with oxygen, and in this case, it does combust. Last sentence, a synthesis reaction is also called a combination reaction. Sometimes, not real often. It's almost always synthesis. And think of the word synthesize, means to make, to put together. And you also see this word synthesis in biology class a lot with what term? Photosynthesis. Rust is also formed by a synthesis reaction. An old metal appliance or a child's metal wagon will rust if it is left outside in the air and rain for a long time. The iron, Fe, in the wagon reacts with the oxygen in the air or water and turns to rust or iron oxide. So multiple reactants, how many products? One. The process is somewhat more complicated, so there is a little bit more to it, but this is a simplified version of it. Decomposition reactions involve one reactant and two or more products. So write it in your notes, decomposition reaction equals a reaction in the general form of AB yields A plus B. So make sure you write down the example here in your notes as well. And it's the opposite, right? It's the opposite of a synthesis reaction. So synthesis, two things, put it together to one. Decomposition, you have your one thing, you decompose it. You break it apart and make multiple products. The name suggests a decomposition reaction involves the breakdown of some substance. The generalized formula for a decomposition reaction is AB yields A plus B. Here is a single reactant breaks down into two different products. Notice that this reaction is the opposite of the generalized synthesis reaction. Typically, some type of energy is needed to make a decomposition reaction proceed. This energy could be heat, light, or even electricity. Electricity can cause water to decompose, which is kind of weird to think about. We don't think about water breaking down or water decomposing. So because my program only allows me to do 15 minutes for free, and well, I'm cheap, I'm going to finish this slide up in the last couple slides in the next part of the recording.